Hello and welcome back to the studio. Today we are doing something really different. As you all know, we're in lockdown, and like me, you have probably spent far too much time on various social media platforms, including YouTube. And you're watching this, so thank you for watching this. But one of the channels that I follow is actually Adam Savage's Tested. I was watching one of his videos recently, and I I was watching it and I was going, "This is awesome. Why don't I 3D print this? This would be quite a nice little CAD project." And you're probably wondering, "Oh, what's he thinking?" So Adam Savage recently did a video, little thwacker, and it's a little hammer, and I just thought it was a really nice project that he used his lathes, various lathes, for a bit of woodwork, bit of brasswork, and I just thought it was a nice project and it'd be quite fun to 3D print. Um, Unlike my usual videos, I'm going to be stepping out of my comfort zone a little bit. I'm going to be using Autodesk Inventor. Now, over the past 3 to 4 years, I've been teaching myself with a little help of another YouTuber, TFI, and trying to learn new stuff. And there's going to be some advantages to this. Inventor is going to allow me to really nicely and very quickly get presumed weight based on the materials that I select. It's going to let me do some parametric drawing. It's going to let me, so I can quickly change and update the shape as if I was turning it on a lathe. And yeah, I just think it would be just quite fun. And then I can export it all as a 3D print file. And what I want to do is actually go through the whole process from drawing to STL conversion, right through to importing into a FDM style printer, and then printing it and putting it together and then showing you the result. And so that's kind of what I want to do today. I think after this, I'll probably make the files available for you to have a look at or download and print yourself if you so desire. I might put it up on Thingiverse. I'm not entirely sure yet. So this is a bit of an experiment to see where this goes. And I think the best thing we can do is get into it. So I'm settled into Inventor, and I'm currently running 2021. I've just got my little iPad down on my right hand corner. You can see me in the corner down here. I've created a project file, and I'm just going to start with by creating a part. So for those of you not used Inventor before, it works in parts and assemblies. So parts assemblies are an assembly of parts. It should be as simple as that. And the way I've actually learned a lot from Inventor and brought that back into CAD in terms of assembly, sub-assemblies, and parts. I'll probably do another video on that explaining my methods of drawing. For the moment, I just want to have fun. I consider this fun, which is not so worrying. So I'm going to start a new sketch. I don't know what orientation I'm going to do. I might do it in front elevation in this case. So I roughly sketched out Adam's dimensions. I'm going to have to duck down and quickly refer to these bits. So I think, I can't even read my own writing now. So I've got 5 degrees taper, and then I've got 214, which can't be right. 51 by 38 was the kind of the stock size it took. So it was about still what, that's a inch and a half. So I've estimated it around 38 by 51. So what I'm going to do, I'm going to do this slightly unusually, I think. I'm going to start with a 2-point rectangle. I'm going to go 51 is my length, 38. Yeah. Okay. Yeah. So when you sketch something by hand and you sketch it on a screen, it looks completely different. It starts to throw you out. So this is the process I go through. It's not always as clean as everyone thinks. So what I'm going to do. Now this is one thing I do like about Inventors. What I can do, if I double click on that, that's dimension 0. So I'm going to do D0. It's got to be lowercase. D0 divided by 3, and then I'm going to do it over 5 degrees. Is what Adam tapered his piece by. So hopefully, no, wrong way. It's the other way. So every day is a learning day. There you go. And then I'm going to go like so. I'm going to match that on that side. Match that on that side. Now I've just realized something as I'm doing this. Now this was a cylindrical object. So what I want to do, I'm going to do a center line. I'm going to mark it as such, which is this icon here. And what I'm going to do, I'm going to split the geometry. I only need to draw the top half. The rest of this is actually irrelevant. So what I'm going to do is I'm just going to shift that into a construction line. I'm going to delete that. And then hopefully when I redo this, I hate it when it does that. I don't know why it does that. I'm gonna then, so green basically means it's not constrained. So I'm gonna cheat and have a look. See, okay, it's basically saying it wants the dimension to say that it's in the middle. Fair enough. Good. What I am actually going to do, I'm going to do it so that it's basically symmetrical between those 2 points. So the thing I like about Inventor, so I've kind of rambled there and you might not have followed. So what I've done, I've drawn a rectangle using 2 points, a center and then out, and then I've created an equation that will change the length of this. So if I double click into this, so D0 is actually equal to 51 divided by 3. Now if I change that divided by 2, all of these chamfers will suddenly change, which is great. It's actually really, really powerful. So what I'm going to do, I'm just going to do Control-Z. I'm actually going to go D0 divided by 2.5 because I think that'll be a little bit more interesting. And it will do all the maths for me. It's worked out, it's 20.4. You can see it's fx is basically saying it's done an equation. And I've told it it's 5 degrees. And these other 4 corners are driven by this one. So if I suddenly go, actually I want it to be 7 degrees, it will change them all. This is what I like about Inventor. It's quite quick and easy to change and do variations. And then the blue lines are things that constrain, green are unconstrained, just covering those who've not used this program before. And anything in dash is kind of construction and not visible and won't be able to make into a 3D. So that's the first part of making my 3D object. And what I'm going to do, I'm actually going to revolve this. And it's already selected the profile, so it's gone blue. And then I'm going to select the axis, which is going to be my center there. And then when I hit OK, I'll end up with a 3D profiled object. Now, instantly, I just like to select the part just to make sure I've got it. And then he made it out of brass. Oh, let's go soft yellow. There you go. Isn't that pretty? Should start using my space mouse so it looks a bit smoother. And that's essentially the first step. Now, Adam actually added in some really nice little, or looked as if he'd added in some nice little features. So what I'm going to do, I'm just going to go back into my sketch. I might just create, oh, I forget, I've got to remember the arc's different in this compared to AutoCAD. So I'm just going to create a arc, and then I'm going to make it 0.5. 0.5? Do I want to do 0.5? Didn't do it the way I wanted to. I had a little freeze there. I think when I run XSplit and this computer just has a little bit of a 0.5. No, it doesn't like that. 1 does like that. Okay, that's weird. So I'm going to take that down to 0.5 now, and then take that down. Oh, that's strange. Why is it put the center there? So if I then constrain this to this line, I can then get that there. And then what I need to do is put a dimension. So I'm actually going to use the points, and then I'm just going to hover to get it angular, and I'm going to do that 5. I'm going to split the geometry again. Now, I don't necessarily have to do this because what I end up doing is getting a load of these little errors. But what I'm going to do is actually leave that and then deselect it in the tool. I'm then going to do another line here, which I'm going to turn into a constructional center line. And shall I do another little divot? Why not? Let's just a little divot, and then I'll do 0.5. For some reason it doesn't like that. Let's see if it likes 1. And then I'm going to go strain that again, 0.5, and then let's make that another 5 mil away. So I do little projects like this just to keep my mind. In fact, I could have done that a really easy way. I don't know why I've done it like that. I just drawn it. I suppose it gives me the ability to make them independent. What I could have done, I'm just going to do Control-Z. I could have gone pattern, or would it work? Yeah, rectangular. And then I would go direction, and then I'd select on that line, switch that, and then go, let's do 3 with a 5 mil spacing. There you go, like so. And then what I'll do is select that geometry, mirror it on that line that I created there, and then instantly. But if I make any changes to this then will adapt all of them. That's what I love about this. So in fact, let's make that 0.75 because we like a nice big feature. So we want it to come out nice in the 3D print. And then what I'm going to do, I'm just going to go into the Revolution, deselect. You can see that instantly when I deselect the main body, I get those rings. I'm just going to hover over and then same on this side. So I've still got the independent choice not to have them if I don't want them. There you go. Mine's a bit more jazzy. And then what I'm going to do is a little round. Let's make that. What did I make? 0.75, wasn't it? Now you see, I could try and remember that. I could actually go into the sketch. So again, this is where I can use this D11 is 0.75. So if I change the size of these, it will change the fillet on the end of this. So in fact, I'm going to use that. So D11, 11 is going to drive this. So if I now change this bigger or smaller, so I'm just going to make it really big, just to make it obvious. Okay. If I now finish, it will regenerate, and you can see it's made that round off much larger. Now it looks, it started to look like one of those squishy hammers, which squeak when you do stuff. So 0.75, I think that's a happy place. Maybe a few too many ribs, but you know, let's have some fun with it. So that's essentially the hammerhead. Now, that was pretty straightforward, and you can see the power of Inventor is its ability to very quickly change parameters to through parametric drawing to generate the shape. Now, the other tool that isn't in AutoCAD that I like is I can go to eye properties, go to physical, and I've told it it's brass, and it will give me a rough weight. So it's about 450 grams, which I quite like. There's lots of other stuff like center of gravity, which is cool, which I think we can relatively predict. So the next step that Adam went through was to put the, I don't know the technical term for this, I should look that up. Maybe I'll flash it on the screen while I'm doing this video. Essentially, I'm going to put the hole in for the handle. Now, in this case, it's a slotted hole. And because this is round, what I'm going to do is I'm going to use the origin planes. That's why I was quite selective. And then I'm going to start a new sketch. And then down at the bottom, there's a tool that allows me to slice through. Huzzah! And so I end up with something like this. And then I'm just going to start a new sketch. Now, if I hit the drop down, again, another advantage that this particular program has, I can actually draw slots in this program, unlike AutoCAD. Looking at Adam, he did 3mm center to center with a 6mm bit, roughly. So I am going to do, now I'm going to try and remember how this does it. I think it does 3mm and then 6, and then that's at 90 degrees. Now, I could reference the other geometry, but I've actually got the dead center because of where I started it, so that's absolutely perfect. And what I'm going to do is take that sketch, I'm going to extrude it, I'm going to select the cut tool, and I'm going to do it in both directions. And then I'm going to go through all. And then I'll end up with this lovely slot ready for everything, which is bloody marvelous. So that's my hammerhead. And what I haven't done yet, which I always preach to people to do, is to save. So I'm going to, I use a weird and wonderful coding system. Let's do it properly, 007, because this is my 7th little personal project that I've done, 01. I'll be honest with yourself, it's the THWACKER head. There you go, so that's drawn. So that's the first part done, which is great, and that wasn't too complicated. The next part is the bit I'm nervous about, is when I go back into part, create another part. I'm going to save this off the bat because I always should, and then all the auto saving kicks in, and then THWACKER handle. So there's not too many parts. It's 2 parts, and so I'm just going to delete that. There you go. So again, I'm starting a 2D sketch. In this case, I will start it in. I've never really. It doesn't really matter the planes because when you come to assemble things, you can twist stuff around. I think mentally, it's just where you think it sits. I'm quite thirsty today, so you might see me sip every so often. So, what do we get for the handle? So I got around 150 to 200 mil guessing from the video, and so if I go 200 mil, and I reckon it's about an inch wide, so 25.4, and he actually had a little snap. So I'm going to go a little bit thicker. And I'm going to go do this in a slightly odd way. I'm actually going to create a construction bounding box for the minute. I'm going to do 28 by 175. I'm going to go middle ground. And then I know that on top of this, I've got the notch section, which will be the insert of the handle. Now again, because this is going to be revolved, I only need to draw 1/2. So what I'm going to do, I'm going to make that into my first center. That's going to be my center line. That's going to be nice and easy. And what I'm going to do, I might change its color. See, okay. So then that's a bit clearer on the screen, possibly. I don't know. Not really clear for me, so I'm actually going to change it to black. That's even worse, Ollie. Just put it at normal. Stop fussing. You're just fussing now. Right. So the handle had a bit of an organic shape. So he went really narrow and then he came out and then kind of did a round here. Now, what I might do is give a nominal distance out. So I might go 10 mil. In fact, I've still got by default construction on, so let's not do that. I'm going to go 10 mil out there. All the wrong buttons today. I'm going to overdraw 10 mil. And then let's say the midpoint is going to be a handle, so that's going to be 5 mil. And then let's do an arc between there and there. And I'm just going to guess a 180 for the minute. So I'm not too worried about that distance. I just want to kind of get a feel for the shape. And then he had a subtle arc here. Do I want... This is, whereas Adam's sitting there thinking about how to shape something, I have to think about how to replicate it in CAD and kind of get that same organic nature. So I'm going to go 5 enough, because that makes it 10 mil overall, which is probably roughly where he is at and why it kind of broke. But it's then when you narrow in the middle where he had his. So what I need to do is just take. I know that that is. Let's clear this up because all these lines are actually starting to confuse me a little bit. What I'm going to do this. I'll reconstrain it all. Don't worry. I will 175, which is fine. But what I'm going to do is split that there. I'll just use the auto constraint. See what it gives me. There you go. It gives me some stuff. That's because that's the center. That's fine. And I'm going to go equals that divided by 2. So that's exactly in the middle. So it's half handle, half body. That's why I've done that. And I'm going to delete that because what I want to do is actually give it a dimension between. I'm going to draw a little line. The midpoint there to the midpoint there. I'm going to make that construction. And I'm actually going to use that as my distance because I want that to be the minimum distance or minimum thickness of that stem. Now I've got to do a little bit of mental maths. To give you an idea of where I'm going, because I can edit this afterwards, I'm just going to revolve. Oh, hello, that's never happened before to me. No valid closed regions. Well, let's fix that, shall we? That's supposed to be like so. You look fine. And you look fine. So what's the badger? There you go. Let's select the axis. This will help me mentally figure this out. So we're kind of looking right. And what I was going to do is then whack on a massive fillet of like 20 mil. Do that. I'm going to whack on a rounding to get our 10 mil. It's starting to look somewhat like. What I'm going to do, I'm just going to pull up Adam's video. I hope I don't get a strike for this. Don't strike me for this. Although I'm so small, I don't think anyone will mind. So, just going to scroll through it, and what I'm going to do, just going to grab that so you can see. So that's the body there, and then I've not obviously carved in my or put in my straight section, so you can actually see he tapers up. So I can almost get away with making that 75% of that length, and then actually having the extrusion, which will fit into my head slightly larger. And I might make the edit to the head to only have 2 stripes, so it is a bit closer to Adam's. So let's just disappear that for now. I'm going to keep it on my other screen just as a reference. And I'm going to go back in to my sketch. And I'm actually going to get rid of the equation on that. In fact, I just had to delete the whole dimension. And I'm going to make sure that that is... I'm going to make that 100 mil. It's going to make it a lot nicer. I'm going to make that... what am I going to make that? So the head was 50. 5, let's make it 150. That makes the whole thing over 200 mil. I'm just going to grab a ruler. Always keep a ruler handy. It's going to be about that big. Handles there. Yeah, it is a little thwacker for a reason. 6 mil though for that core. I'm just really worried about that snapping even in 3D print land. I think it's thicker. I think that's got to be at least... I said the base had to be at least 25 mil, didn't it? So I am going to go 28, so that needs to be 14. Which means that should be 7, which means I can make that 5. 7 again. Gives us a bit of a better shape, doesn't it? Again, this is the beauty. I can keep editing and getting that shape right to what I want it to be without having to worry about bulbous. Maybe not. See, visually it doesn't look right. So let's make that 75, and then that should even us out a bit. There you go. That feels a bit more reasonable. It's still quite chunky. Maybe that wants to be smaller. How does that feel? Does that feel better? Oh, it doesn't like that. It won't like the fillet. That's why. Got to make tricky because I'm like, that middle bit needs to be this. This is where CAD falls down. We will literally spend hours going, I wonder. Let's make it 8. I feel comfortable with 8. So then let's make that double. That becomes double. And in fact, what that should be is equals that over 2. So let's use the parametric so we get a decent shape. And then let's make that the master. That becomes a little bit longer. Let's make that 160. Like so. And then we get a bit of a handle. And then what we're going to do is actually carve out the bit that we need for the head from this. And the reason I'm going to do that is so I don't end up with this weird fluting shape that comes up. And the fillet's not going to work because that is far too small. So that needs to be, let's make that 6 for now. And some sort of ash from memory. I don't actually remember. What options have we got? Wood. A maple? No, that looks awful. Oak. That looks bad. Walnut. Okay, I'm going to change my view because that looks weird. Looks really odd, doesn't it? Not wood, not inventor's thing. Got a birch. Who doesn't like birch? Right. In fact, let's just do a little bit of graphical. Let's throw on some shadows and reflections, make it look pretty. I'm sorry, I'm in a happy land of my own. This I do really genuinely find this fun. I'm then going to grab this, and then I'm going to do my same thing again. So it's 3 and 6. But interestingly, this time, last time I cut that out, and I'm not going to cut this profile out. What I'm actually going to do is then do a circle. And I'm going to do it 25 mil just for ease. I'm going to extrude the internal profile, as you see here. Like my Instagram post, very good. I'm going to go that way, and it's going to cut, and I'm going to go 50, 51. 51 mil. And instantly you can see how far down that's going to go from just that shape. So we need to do a bit of an extension there and make it a little bit. Is it 51? So I'm just going to hop back. It's 51, isn't it? I can quickly check. 38. Oh, God. Totally the wrong number. What am I thinking? Let's change that to far more reasonable, he says, not believing it. But again, here, what I can do is actually, I am going to make it overall 200, which is then going to, that looks much better. That looks much better. So, nice. I'm happy with that. And what I could do is actually put a little hole in it for a little lanyard. So I'm just going to show you how to do that. So again, same process as I did on the hole for the core. I'm going to slice through the graphics. I'm going to do a little circle just down here, and then let's make that. Oh, now remember, Inventor, unlike AutoCAD, does diameter, so I'm going to do a nice little 8 mil hole. Now I didn't constrain that. That's rather naughty of me. So let's constrain it because we are good. And from the very center, $70. In fact, what I should do is just use, puts it 10 from the bottom, which is actually a more useful dimension if we're honest. The 70 is pretty arbitrary. So let's do it from there. So what the yellow line means is that I've just projected some geometry from the existing, and then I'm just going to vertically lock that in so it's definitely center, and we can be sure. I'm going to extrude that both ways, cutting both ways, and then I will fill it. So we'd give a nice little round off to that. Not quite 2 mil, maybe 1 mil. Ooh, let's try 1 mil. Let's not try and take the bottom of the handle off. And there you go. We've got a nice little grab hole. Now that it's quite far down. Again, it's me going, really? So let's make that 20 mil. So a bit more of the chunk of the handle. There you go, that feels better. And then what I want to do is save that. I don't really need to close it. So I'm going to start an assembly file. And from here, what I'm going to do is actually place these components in. I'm going to go like so. I'm going to place this grounded. I'm going to ground the head, no particular reason, one way or the other. It's just that's file number 1, and then I'm going to grab this file, and then I'm going to constrain. Still a badger, like well, there's so many different ways I can constrain this. I could constrain circle to circle, and then bring that flush up to here. But I think what I'm going to do, I'm going to try the insert and see what that does in this case, because obviously it's not complete because of where it's kind of carved. Now this is where we find out that we're not going to get the, no, we're not going to get this lot of circles. So Ollie, you're just going to have to slum it. So instantly that's now constrained in that direction, and then what I'm going to do is constrain this over here. Don't care about the direction. And then what I need to do is then make this flush to the top. So awkwardly I have to do, if I do this element, I can do it to this bridging line. And then that is a little THWACKER. Now I'm actually going to go back and edit and remove this line, well, one of these lines. So what I'm going to do, I'm just going to grab that suppress element because I don't want that, because I only wanted 2, and then I'm going to suppress this as well. Oh, because it's a mirror, I can just delete that. Oh, it's having a little having a moment. Is that because I defined the fillet off the, not sure why that's happened like that. Oof, interesting. I love it when CAD throws a little quirk. So this can sometimes happen, which can be a little bit frustrating. but it's okay. We live for these moments. And then the fillet is fine again. Amazing. And then we're a little bit closer to what we need to be. I'm going to hit save, and then when I go back to my assembly, there you go, all nicely done. Now I just want to do an update. And that's essentially drawing a little thwacker. Ah, my whole direction is not the direction I wanted it to be, so I just need to delete that and delete that fillet. Because I've done it in the wrong orientation, because remember, that is going to be the direction of the hammer. So I actually need it through a different plane. I need it through the YZ plane. So let's do it on here. So same process again. I'm going to slice graphics. I am going to project a bit of geometry because I want this as a reference. I'm going to draw a circle. It is 8mm. Up from there. Oh, let's be risky. Let's risk the biscuit at 14. 14? 16, because then the center of it's at 20. No, that is the center of it. What are you talking about, Ollie? Talking out of your arse. And then vertically constrain. Because why are you showing me that? Right direction? Okay, weird. And then exactly the same. Cut through all. There you go. Little fillet just to finish her off. I can grab both sides. And there you go. A bit nicer. I'm going to hit save on that. Hit save, and then I'm going to save this assembly because I haven't saved this assembly. Nice, okay. I'm pretty happy with that. Now, one detail I've not put in is in real hammers, what you do is actually split this top. And what I'm going to do is just draw in a little split, and then I'll actually wedge something in there. I suppose I should draw something to wedge in there. Now, with 3D printing, we need to do a certain size of wedge. So what I'm going to do, I'm going to use a 2-point rectangle again. And I can do this oversized because it doesn't really matter. Let's do it at 2mm. Going to be ridiculous. And then I'm going to take it down. Again, extruding. Opposite direction, so it automatically goes into cut. And let's go. I'm going to leave it like that for a second. What I'm going to do, I'm going to look at the extrusion of my cuttings. That's 38, and that's showing me as D17. So you just see it hop up there. So I'm going to do that divided by 2. And then it's parametrically driven. And then I can use that as my wedging point. And what I'll do, I'll just wedge something I've got in the studio in there. Or I'll 3D print something. Oh, I should just draw something. Won't take me 2 seconds. So you can see there, I've got a nice little wedge. And what I can do, again, being in 3D printer land, do a little, make life a little bit easier. I like that. What I'd like to do is also just add in that. Don't know why, just want to, just because I can. Okay, and then so we need to make a new part that is, let's get some dimensions. So going to the tools, 18, ironic, 18mm by 6. Cool. So let's just generate a part. Again, doesn't matter. Go. And I did it by 2mm. So to get a tight fit in 3D printing, we do around 0.1, 0.2. So what I'm going to do, I'm going to make this one. What do I want to make this? It's 2mm gap. Let's make this 1.8. I'm going to try this first, and then I'm going to just round off try and make it a bit easier to, and I'm just going to take the extrusion height, so D2. Trying to make this nice and easy to put in. Nice wedge. It doesn't matter if that doesn't touch the sides. And again, this in reality would be, well, Adam used a bit of a ring washer, so I'm going to stick this in steel. Ooh, steel is not pretty. Let's do that in stainless steel. No budget. Spacer. And I'm going to jump into place another component. Spacer, and I've totally misnumbered that, which is really bad of me. That's really, really bad of me. So I'm just going to do file, save as, naughty. This unique part numbers are really important, and I didn't even do capitals. Oh God, really let myself down. Spacer, and yeah, okay. Didn't want to fill it, so I'm gonna hit save because I don't need that right now. I don't need that. I don't need this right now, and I don't need. That's done. I'm gonna go place component. Number 3. And again, I could have rotated at this point, but what I'm going to do is I'm going to constrain. I want this to be flush with this. I want this face to mate with this. And have I made a rod for my own back in terms of positioning? Have I made a rod for my own back? I possibly have. By trying to make this really easy to. Can I do? That's not going to do well. Good question, Ollie. How do I position that there? Let's have a look. So what I'm going to do, I'm going to grab another really wonderful tool of this that works just really well in Inventor is the section view. And you can see how that's going to integrate. Tangent. That's it. I'm going to go like, and I've just moved it out of the way. Which is not what I want to do. So I'm going to do end section view. Constraint. I'm going to use a different type of constraint, which hopefully works. Go on. Yes. There you go. See, sometimes just needs a little bit of memory. And that's my little thwacker. How cute is that? Am I convinced by the birch? Probably not. But let's have, and that's the process. Literally, I just wanted to draw something for fun, just to see if I could do it and keep my skills up. Because for those of you who are learning CAD, and for me as learning Inventor, I need to practice. And I find projects that I enjoy, or if I'm excited about, or if I'm passionate about, I learn more and I remember more. So for me, this was something I've sat, and I think this video, when was this video released? 29th of April, this video was released, and I've sat since 29th of April going, I'm going to do this video. I really want to do this. I want to do a little thwacker, and I thought I'd bring you along this journey. You might just think this is the ramblings of madman, and that's absolutely fine. So what I'm going to do now, I'm going to hit save, because I'm pretty happy with this overall. And I'm going to export these files for 3D printing. Because I just think it'd be a nice, fun finish for this. But what I'll also do is do a nice little ray trace, but I'll time lapse that because that can take some time. So what I will do, I'm just going to open up, of course, after I close, I'm going to open up the elements. And I'm just going to grab that last. I'm sure there's a quicker way of doing this. Oh, the task scheduler certainly does this better. I just want to do this myself. Actually, there's something I've just remembered. What I do need to do, because I am 3D printing this, I need to adjust this top cutting extrusion here. Like I said, in 3D printing, we put a bit of tolerance in. So what I want to do is actually make this slightly smaller. And what I can do is essentially do that by, I'm going to go back into the sketch. And so if I go overall length and then go minus 0.15, because that gives me 0.3. So it's going to give me room to expand. In fact, I hit enter a bit too. If I change that to minus 0.1, that makes sense. Is that going to be a sensible amount? This might still be tight. I might need to do some sanding. So I do want it to be tight. I want it to fit nicely. I want it to feel. Let's do 0.2. I'm willing to risk it. With the expansion, I think we might be all right. This is why I can't even get the expander in. There you go. So that will now what this will cause, frustratingly, when we actually go back to the assembly, is it will face to one side. So what I need to do is actually take one of the constraints, which is the mate, and put 0.1 in there. Accept my relationship, please. I need to delete that one because that's essentially what's holding it in, but that can't exist anymore because constraint. Can I do a constraint between this and a line? Can I do dash? Will that work? No, we have to do it. That seems happy with that. Don't know if I'm happy with that. Like a lot more room than I thought it was, and this is something that's quite useful. I can just quickly grab. Saying 0.4. That's definitely not what I want it to be. It was all looking so successful up until this point. This is the beauty. I can make little adjustments. An issue all of a sudden. Accepted, damn it. Things that make you go, See, I've really messed this up by doing these edits. So this is why I should have thought about this sooner. And that's flying around now as well. A little bit of reassembly required. Good for making me think, because that's tangentially. In fact, if I cheat while I have this, what I can do is go ta-da-da. In fact, I need to look at that height because that's definitely not right now. What's going on there? That should be the 38, 31. Something got mistyped there. There you go. So that's the handle. That's great. That's what we want. That's why it was throwing a paddy at me. It's because I accidentally messed up the Yoo-hoo, which is totally my fault. Not going to like that either. That's fine. So let's get rid of that. Does that help? Help. And yet you're happy with that. Who knows why? Let's see if I can make you happy with this. Nope. Oh, you're going to be irritating, aren't you? Okay. I'm going to come back to this in a minute. Right, sorry, I had to switch off for a minute. I actually couldn't figure it out. What I'd done is, in this component, I'd done the wrong thing. I'd essentially reduced that distance and the radius, so it was giving an offset. So 0.4 on one side, 0.1 on the other side. I just need to reduce the diameter of the circle, and then it would give an equal thing all the way around. Absolutely fine. Great. Solved. So now I've got all the components right and exactly how I want them. I'm going to save. Hit save. Don't ever let go, Jack. And then what I'm going to do is I'm just cycling through them so you can see them. And what I'm going to do is just snap to isometric. Then I'm going to go File, Export, CAD format, and I'm going to create a new folder, STLs. I'm going to options, make sure it's in high, because I want a nice high resolution file. I'm going to hit save. I hit spacebar to repeat. Save that. Spacebar to repeat. Save that. Now I operate two 3D printers, a MakerBot Z18 or Z18 depending on which area you're from, and a Formlabs Form 2. Now in this case I'm going to FDM print this. I don't really want to spend the time hollowing out the components to try and save some money on the resin because it's quite expensive. In this case, because it's size, I'm going to FDM print this. So I'm just going to switch over to my slicing software. Now some of you might be thinking there's better slicing software out there. In this case I'm quite happy. I'm just going to use MakerBot's own, and I'm just going to grab the STL files, which I'm going to insert. So I can just do this by dragging and dropping them in. I might have to make the spacer as its own part, just because it's quite small. But essentially, this is what we're going to build. What I'm going to do, I'm going to rotate this. It's not going to do with any scaling. So I'm going to rotate this in the y-axis minus 90 degrees, so I can print that hole circularly, and then that is supported up to there. Then I'll have to remove support along this edge. In terms of the hammer, I'm going to actually place one of these faces down like so, and then support will populate in here, and then I'll sand that out. I think that's going to be the most efficient way, otherwise I'll end up with support around this lovely face. Strength wise, does it make sense? I don't think I'm too worried about that. And then I'm just going to plonk my little one down like that. And then I'm going to hit arrange build plate, and MakerBot will do the rest. Looking at settings, I'm going to quickly run through these. I'm going to do a separate video on 3D printing, so don't worry. I'm just looking at these. I'm going to increase the infill density to 15%. I want a 30 degree because I have good results with that. 36 millimeters, or let's treat ourselves to a high resolution. I'm just going to do shoe shells because it's just going to be a nice model, and then I'm going to drop that to 45 degrees. Breakaway support, and I'm going to select my printer, which isn't appearing, but that doesn't matter at this point. What I'm going to do, I'm going to set it to export, and then I'm going to hit for it to estimate preview. And now what the computer does, it essentially will work through the model to work out the most efficient paths and tooling paths, and then momentarily we should have the tool paths. Cool, so the model has now finished slicing, and I can work through the layers to see how this is going to be built and how long it's going to take. So in this case, we're going to be less than 50 grams of PLA. Great, that's nice. And it's going to take 4 hours 36. Now, because I've combined this onto one build plate, it means that everything is going to be the same color. If you wish to print this in different colors when I share the files, that's absolutely fine. I'm pretty happy with that. So what I'm going to do, I'm going to export this onto a USB disk. So I've got a 3D print drive, and I'm just going to call this. Name at this point doesn't particularly matter. Some 3D printers actually have the ability to track prints online, so naming might matter to you if you use like counting, so you want to tag it back to a project. But here we can see 50, it's around 4 hours 36, so it's about it's literally 6 o'clock now, so 10:32 tonight this will be ready. But I will time lapse the making process, and let's see how it goes. 2 or hour 5, depending on how you're tracking time, and this is the build plate from my 3D print. So what I'm going to do now, I'm going to remove it from the build plate, which is a kind of a Teflon surface, and normally I can just flex, pops off like so, and then I'm left with the parts on the raft. And now what I need to do is just carefully remove all of them from the raft, and so not to bore you with that, I'm probably going to speed this bit up just so I can get it all into its parts. Well, after that little bit of support removal and sanding you've just seen, we are left with the lovely little THWACKER. I'm really pleased with how this came out, and actually when I thought I printed it, I thought, oh, I don't know what I'm going to use it for, it's just going to stay on the shelf, and already I've been hitting things around the studio going, why don't you just work? Really, really pleased with how this project came out. It's from start to finish with just over it's 4 hours 20 minutes for the print and just over an hour-ish for the drawing. So as an end-to-end design to delivery, that's 5 hours for those of you wondering. I just dropped that successfully. I've been editing this as I go along, so apologies, this is a very long video. I hope you enjoyed it. If you like this format, please drop me a comment below and I'll do another one like this soon. But thank you for joining me, and catch you in the next one.